My created problem. I'm Jacob Wagner. This is my problem I created for Newton's second law of motion. A process operator is testing a loaded conveyor cart system that moves material across a plant. The total mass of the cart and material is 75 kilograms. Determine how the motion of the conveyor cart changes over time by answering the following. Calculate the acceleration at each time interval using the given force values. And then I'm going to be describing whether the cart's motion is constant or changing and explain why. This is the relevance of the question to topic explained. This question is directly related to Newton's second law of motion because it focuses on the relationship between force, mass, and acceleration. The problem uses changing force values applied to a conveyor cart system while keeping the mass constant. According to Newton's second law, when force changes and mass stays the same, acceleration will also change. This makes the question relevant because it demonstrates how motion is affected by force in a practical situation. Benefits of understanding question given. Understanding the question helps students learn how physics principles apply to real-world systems such as conveyor belts, carts, motors, and industrial equipment. It also helps develop problem-solving skills by requiring students to organize data, apply formulas, and interpret results. Knowing how force affects acceleration can be useful in engineering, mechanics, and process operations, where equipment performance and safety are important. Process of writing the question outline. The process of writing this question began by selecting Newton's second law as the main concept. Next, a realistic scenario involving a conveyor cart was also chosen because it is easy to visualize and relates to industrial motion systems. Then, values for mass, time, and applied force were created in a chart format so students could calculate acceleration step by step. Finally, follow-up questions were added to encourage analysis of whether the motion was constant or changing. Uniqueness of the question discussed. This question is unique because it combines a common physics principle with an industrial style application rather than using a basic classroom example such as pushing a box. Using a conveyor cart system makes the problem more practical and realistic. The use of increasing force values over time also add variety, since students must analyze changing acceleration rather than solving only one simple equation. This is my relevant chart. You have your times 0, 3, 6, 9, and 12, and your forces applied 50, 150, 300, 450, and 600. That's the numbers. Relevant formulas, constants explained. To solve this simplified Newton's second law problem, the following formulas and constants are needed. Primary formula, Newton's second law, force equals mass times acceleration. This formula shows the relationship between force, mass, and acceleration, where force, F equals force, is the Newton's, mass, M equals mass, which is your kilograms, and acceleration is A, is meters per second squared. Rearrange formula, solve for acceleration. Acceleration equals mass times force. This is used because the force values are given and the mass is known. relevant constants and known values. Mass of conveyor cart system is 75 kilograms. Force values from the chart: 50 newtons, 150 newtons, 300 newtons, 450 newtons, 600 newtons. Your time values: 0 seconds, 3 seconds, 6 seconds, 9 seconds, 12 seconds. And why these are relevant? Use acceleration equals force divided by mass to calculate acceleration. Oops. And the solving process thoroughly described. I'm going to calculate the acceleration for each time interval, considering Newton's second law. Then I will move on to analyzing motion. Step 1, identify given values. Mass equals 75 kilograms. Formula: A equals force divided by mass. Acceleration equals force divided by mass. And step 2, calculate acceleration at each time interval. At 0 seconds, A equals 50 divided by 75, which is 0.67 ms squared. And at 3 seconds, it's 150 divided by 75 is 2.00 meters per second squared. At 6 seconds, it's 300 divided by 75, and it'll give you 4.0. So it basically goes up 2 every time, as you can tell. 4.00 meters per second squared. At 9 is A equals 450 divided by 75. So it's 6.00 meters per second squared. And at 12 seconds, A equals 600 divided by 75, which equals 8.00 meters per second squared. And then step 3, you analyze the motion. I discovered that acceleration does increase at each interval. Acceleration increases at each interval because the force applied will increase while the mass is constant. The acceleration isn't constant, and the motion changes by accelerating more every time. And there you have your final answers. Accelerations: 0.67, 2.00, 4.00, 6.00, and 8.00. All of those are meters per second squared. And the second cart motion is not constant because the acceleration increases as the force increases over time. This was also given to my classmates, and Kai solved it correctly. Additional valuable information provided. I think Newton's second law of motion is valuable to learn because it explains how force causes an object to accelerate. It helps show the relationship between force, mass, and motion, which is most important in many areas of physics and engineering. Additional student interest described. This was me. I find it interesting that Newton's second law of motion can be seen in everyday life, like driving a car, pushing heavy objects, sports, machinery, and pushing a baby cart, so on. Learning about it makes physics easier to relate to in real situations as well. Overall summary of topic presented. In my view, Newton's second law of motion is one of the most important principles in science because it explains how objects move when force acts on them. And understanding it provides a strong foundation for mechanics, engineering, and problem solving. And these are my sources used and my